Today we'll be talking about Arduino-based ultrasonic parking assistant. My name is Herman Lopez.
My name is George Cortez.
My name is Santiago Silva.
My name is Olivia Arroyo.
This presentation will outline the following: introduction, research, statistics, systems components, systems operations, benefits and implications, challenges and collaboration, design complexity, assembly demo, code walkthrough, and conclusion. Project inspiration and story. Picture this invention at a scenario where vehicles are meticulously organized in urban, educational, and corporate landscape, mirroring the meticulous engineering of a sophisticated apparatus of motivation is deeply embedded
in addressing
the
multifaceted
challenges inherited to parking in dense cityscapes. Vibrant college campuses and the demanding businesses milieu.
Okay. Our vision. In the face of these challenges, our team has envisioned a future where technology not only eases the parking process, but also enhances safety. Purpose, design, ideation. So our purpose is to revolutionize the way we park by creating a smarter, more secure, and convenient solution. As displayed in this diagram, you got the frame light source sensor. We're achieving this vision by harnessing the power of Arduino technology, integrating the ultrasonic sensor, LED lights, and a buzzer to develop a cutting-edge parking assistance system, which this system employs real-time distance information, transforming the stressful parking experience into one that's safe, accurate, and stress-free. Olivia.
The research statistics on parking garage accidents. Some data points that come to mind are 59% of American car owners have experienced damage to their parked cars. Among them, 23% actually reported the incidents. A few regional variations we might go over. About 65% of Northeasterners most likely are to experience the damage while parked. 54% of Westerners are less likely to encounter such accidents. Income influence. High earners that usually have an annual income over 6 figures face more parked car damage, about 69% of them. Those with incomes below $35,000 experience at 51%. Location matters. 66% of incidents occur in garages or parking lots, structures. Baby boomers aged 57 to 76 see this rise up to 76%. 32% occur on the street and 12% in driveways. Damage causes. 44% result from another vehicle hitting a parked car. 29% due to the car doors hitting other cars. 9% involve car keying. 6% caused by broken windshields or windows. 11% remain unsure of the cause. Responsibility. 23% of American drivers admit to damaging others' parked vehicles. Gen Zers, about 37%, and high-income earners, about 34%, are at the top of this list. Common causes: vehicle collisions, 47%, and car door collisions, 36%. Other causes include keying, about 7%, and breaking windows, 1%. Surprisingly, 49% of these individuals also find damage to their own cars.
System operation. So the ultrasonic sensor emits sound waves in a specific direction upon hitting obstacle, a vehicle in our case. These measure the time it takes for the waves to return. The Arduino processes this time data, converts it to distance measurements using speed of sound as a reference. The LED lights indicate the information with red, yellow, green lighting up, allowing the driver to gauge the proximity of the vehicle to obstacles. The system operates in real time as the vehicle approaches or moves away from the obstacles. The driver can easily interpret the color of the LED lights to determine how far to proceed while parking. The system includes audible alerts such as beeping sounds that activate as the vehicle reaches the maximum boundary, further enhancing the parking experience. System components. Ultrasonic sensors, which is the core of the system, including one ultrasonic sensor strategically positioned on the boundary of the designated parking spot meant for a driver. This sensor emits high-frequency sound waves and measures the time it takes for the waves to bounce back after hitting nearby objects. Now, the LED lights provides visual feedback on how close the vehicle is to the ultrasonic sensor. There are two sets, green, yellow, red, accordingly, representing closer to the sensor in which the drivers are able to know the indications of the LED lights. Arduino microcontroller, the brain of the system, most importantly, receives and analyzes data, ultrasonic sensors. It processes the distance measurements, controls the output buzzer, which is the noise for the final red LED boundary.
The benefits and implications of this project. This Arduino-based ultrasonic parking assistance system offers several key advantages. The first one is safety. This system reduces the likelihood of collisions with obstacles, improving overall road safety. The second one is efficiency. Drivers can park more precisely, optimizing the use of parking spaces and reducing the risk of vehicle damage, and also allowing for more cars to be parked in parking garages. This system is user-friendly. The LEDs provide easy-to-understand visual signals and the amount of room the driver has from the boundaries of the parking spot. The buzzer also provides auditory feedback when the driver has approached the absolute maximum of the boundary. This system is highly customizable. It can be adapted to various vehicle types and parking scenarios. In a world where parking spaces are increasingly limited and vehicle safety is paramount, this project demonstrates the potential of Arduino-based technology to enhance driving experiences.
Challenges and collaboration. So me and Santiago, we collaborated based on the coding, defining the distance values, and redefining that one code, which that green LED light, which I'll show really quick in this video. This is the beta version. So I'll pause right there. So the second LED light, which was the green one, didn't work, which Santiago is the one that redefined it. He'll further talk about it.
Yeah, so in George's code, at first, the code was a little out of order, so I noticed that the Arduino was reading it out of order. So I went back and deleted the whole section with the LED lights and started from scratch, and we were able to get the project working at the end of the project. Okay. And our design was very complex. It involved 6 LEDs, a buzzer, an ultrasonic sensor, and the 7 resistors. The LEDs all had every component has a purpose. The LEDs measure distance. The buzzer tells you the absolute maximum. The resistors limit the voltage, and the sensor tells us the distances. For the code, so at the top we can see that we're defining the trig and echo pins. Those are for the ultrasonic sensors. Underneath that, we're defining all of the LEDs in order so that we know which one is meant to go off. Underneath that is the buzzer. And in the setup, we just defined each pin, made sure that each pin was a designated value. In the loop section, we see where we have the ultrasonic sensor going off, and after that, it prints the distance for us every 2 milliseconds. And if the distance is between those values that are and underneath where it says control the LED based on the distance, between those values, the certain light will go off, and at the penultimate boundary, the buzzer will go off.
The closing thoughts. The Arduino-based ultrasonic parking system with LED lights and a buzzer offers an innovative solution to the challenges of parking in congested and confined spaces. By utilizing an ultrasonic sensor and an Arduino microcontroller, the system provides real-time distance information to drivers, promoting safe and precise parking. The project showcases the potential of open-source hardware and demonstrates how technology can be improved road safety and efficiency in urban environments. These are a few of our references that we use.
Just one of them, which was the research statistics.
Yeah, we first.
A lot of our work was original, so the only statistics we used were for the parking garage statistics. And these are our roles and responsibilities. Everybody had an equal role in creating this project, and overall it was a success, and we're happy to provide a working prototype.